Hey, good morning, folks. Seem to be off center from my computer. That's weird. Like, well, that's not so weird. Okay, well, it's kind of like the way my chair goes with this desk. I have the other computer next door, on that side of the desk, the newer one. All of my stuff is on this one, so it's like, what do you do with it? You can't. You keep it. Unfortunately, this is the only one that has the video camera. I didn't want to get one for that one. I was like, why? They're ugly. I like it when they're embedded into the computer. Well, it's been a while. I apologize. I just recently published my last video. It's an hour long. That was a lot of wasted wind I had because I had no sound. So it had been so long since I did one of these videos that, of course, they had updates. So I updated the program, and in so doing, it did something about my sound, shut my mic off or something. I'm not really sure how it happened, but anyway, a friend at work, dear Mr. Jamie, let me know there was no sound. So I'll be taking that one off, and maybe it's a better thing, because what I want to do right now is talk about the universe the way I see it, and the solar system, the sun, and the earth, and what they all have in common. It's really intriguing. I find it exciting. So anyway, the GMRT, and give me a second here, I'm going to go down here. The GMRT is the giant, if I can find the acronym down here in my literature somewhere, the giant blank radio telescope in India. Yeah, if you can figure it out, you can find out. It's a giant telescope in India. So basically, anyway, we have this giant telescope in India that photographed this anomaly right here, and all of this red stuff is neutral hydrogen gas that's just basically floating around the AGC 203001 galaxy, and the scientists are wondering what it is. Me too. The more I looked at it, I was like, well, that's interesting. And it's like, how do we know what that is? I guess we don't. So as I'm looking at this photograph, as you can already see right here, basically, these are my later photographs. This is like change 2. Yeah, I have change 2 up here. So if we go look at change 1, nah, never mind. I didn't send change 1 to this computer. I did all this stuff on my new computer. Darn it. Anyway, this is change 2. And what I did is I took a circle and I plotted a circle, a very circular circle, right there on top of AGC 203001. And I didn't do that until I already, in my mind, I could see element 1 as we have up here, AGC 203001 here, element 2 here. Both of these are brought to the reader's attention in the article that presented the photograph. Element 3 and element 4. Now, here's the thing, right? Whatever is happening with AGC 203001 is happening with element 2, is happening with element 3. And as I put the circle to these objects, it was extraordinarily close to the arc that we could see. And then I decided, you know what? I'm going to go ahead and skew my circle until it becomes an ellipse. Skewing my circle into an ellipse, I was able to pass the perimeter of my circle through each one of these elements. Now, I don't have lasers to go shooting these elements, not that I'd get a reading back within my lifetime for their distance. But, you know, scientists have a way of figuring out their distances. I'm going to turn that guy off. Oh, wait. Oops. Okay, that's good too. Anyway, we got this great big monster circle here, right? Now, that means that the center of the circle is over here somewhere. I was expecting to find something over here somewhere near the circle, but I didn't. And basically what we have here is we have these objects that appear to be orbiting something in this region, except there's nothing there to orbit. So if there's nothing there to orbit, what is this, right? I'm looking at it and I'm like, it's a wormhole. So what we have here, in my mind, Mr. Gemmell's universe, we have the event horizon where all of these 5 elements are floating along. They are right at the event horizon of this wormhole, and you don't know it. It's not a Hollywood wormhole, because it doesn't have that really fantastic dazzle your eyeballs with motion going on. It's just what you see are the way that the objects in space are behaving around this area of the universe, right? Okay, now here's the other frightening thought. These guys have neutral hydrogen gas. So what's likely to be the cause of gas becoming neutral? The closer it gets to 0 Kelvin, possibly, the more likely it's going to become neutral. So with theories I've passed on before, where I'm talking about the cosmological constant, running off of Einstein's name, the cosmological constant. I do believe that Einstein was correct about both theories. There is a cosmological constant, and we have an expanding universe. Both. So as perplexing as it may have been, it's not one or the other. Just like plate tectonics and vortical tectonics are not one or the other. It's both. Took me a while to figure that one out. All right. It took our ice caps falling apart to teach me that lesson. So here we are, right? We've got this vortex thing going on, and as I'm looking at it, because of the particular obliquity of the AGC 203001 in relation to this ellipse, I determined that the rotational direction of this ellipse is in the direction of this arrow, this yellow arrow. And I called that my universal jet stream direction of rotation. I'm referring to this wormhole as a universal jet stream because I'm not really certain. At that point, I really wasn't thinking that it might be a wormhole. Now I'm thinking it might be a wormhole, and this is why. If we were in a universal jet stream, say for instance around a like hurricane structured universe, we would be going this way, and our galaxy would be angled like a jellyfish swimming through that here my coffee diggity do. We'd be like this, swimming through the galaxy, swimming down like the flight corridor, swimming through the universal jet stream. Well, that's not the case here. The case here is, at least in my mind, is that this is a wormhole and we are flying like this. And so as I'm looking at my computer screen, I'm looking at this particular obliquity of that wormhole ellipse relative to my point of view. And it basically means that just off behind me here is the funnel of this wormhole, okay? And so that means our galaxy is like headed straight for, oh gee, guess what? The event horizon of this, the theoretical event horizon of this theoretical wormhole that exists in space that you can only see because of the objects flying around it. And no, there's not so many lit objects flying around it that it gives you this funnel shape. There's not enough in space, excuse me, I don't know, my keyboard. There is not enough space like that out in space. Or what am I talking about? There's not enough light like that out in space to give us that kind of view, right? So as you look at it here, I put this like nice pretty little green line to describe how I visualize the universal gravity waves of this particular vortex, and they come out like dragging the rope. So that means the vortex is rotating this way and the rope is being dragged in the opposite direction. As that wave ropes through and gets dragged, it hits these objects and it causes them to rotate. So it's actually the power that's rotating this galaxy. But here's the problem. And what I determined was we are flying toward this particular view of this theoretical wormhole. And what does that mean to us? Well, it means that our galaxy is rotating in the opposite direction of AGC 203001, and that means that doesn't make sense, because if this vortex is rotating this galaxy, it's also rotating our galaxy, and we might be somewhere really close to the funnel walls of this wormhole. And what that means is we're heading toward the wormhole. We are going from, we're at the back side of our galaxy is pointed toward the very small end of this fluted wormhole. Do you understand? So we are going toward the big side. We see it, the big one, because we're actually flying toward the big one. And what does this tell us? It tells us that this particular wormhole, if it really is a wormhole, is cyclonic. What does that tell us now? Now I'm going back to my DRCB, vertical theory of operation, which I am convinced exists, and I have found proof on the sun that the sun has alternating currents just like Jupiter, just like the Earth. Okay, and I'm putting it all together for everyone. It's a discovery, and it goes completely against anybody's theories of plate tectonics being the sole source of operation on the surface of this planet. And actually, plate tectonics is going to take a back seat to vertical tectonics. But right now, I'm trying to figure out this view of this galaxy, and why does it have neutral hydrogen gas, where stars cannot be formed. Okay, that's alarming. And basically what it points to is this is our future, because that's where we're going, ladies and gentlemen. We're heading, our galaxy is flying toward AGC 203001's current position on the theoretical event horizon of this theoretical wormhole. And if it's cyclonic, and if the universe that we live in is a DRCB in and of its own nature, maybe a little bit different, because we have differences between Jupiter and the Sun, in that Jupiter's core is so horrifically dense that it forces the equatorial vortices north and south. So the vertical rods, there's one vertical rod north, one vertical rod south, as opposed to the Earth and the Sun, where the vertical rods are almost perfectly equatorial right on that equator. So there are small differences, but the overall general operation is the same. So if we have that similarity here, that means that if this is a cyclonic vortex, we are being pooped. I know it sounds funny. We're a universal poop. Our galaxy is universal poop, but that's what it's pointing out to me. It says we are universal poop, and we are just about to become the fecal matter of this universe. We are, everybody's talking about we're at the end of the universe, or what happens when we get to the end. We're going to find out real soon. In fact, we're looking at AGC 203001, and oh, by the way, that's what's going to happen to us when we get there. That's what's going to happen to us when we get to the end of our universe. Ladies and gentlemen, by me looking at this photograph, what I see that we are heading toward the bottom of our universe. We are heading toward this event horizon, which eventually will neutralize the hydrogen gases within our galaxy, and we will begin to look just like AGC 203001 when we get there. This also goes in, helps to explain why Andromeda, from my point of view, I always envision Andromeda to my left. So for you, it's Andromeda over here, and here's the Milky Way, right? And we're on this like collision course, is what everybody's telling us. So until I ever really figure out the absolute obliquity in relation to these two galaxies, I won't be able to tell you whether or not they really are on a collision course based on the jellyfish approach, right? Not the flying saucer approach, jellyfish approach. Now, what is it that we notice the most about our flying saucers? All of our stories about flying saucers, I know we're talking about UFOs. Every time somebody says they see a UFO take off, what does it do? Does it do this? Does it go? No, usually it just goes straight up, right? Just like a frickin' jellyfish going to the top of the water. Yeah, because that's the way things fly through space. Not aerodynamically. You got to be aerodynamic in an atmosphere. Space isn't so much of a thick atmosphere, so like you might be able to go faster if you go straight through it head on. You're not slicing anything. There's little drag, if any, and you just need propulsion. So, but trust me, there's something there everywhere. In my mind, in Mr. Gemmell universe, there is no such thing as a microbial space in anywhere in the freaking. I like that word. like the space is living. Well, it provides life, right? There's something there. We just don't know what it is. We don't know how to find it. We can't see it, but it's there because it creates like an embodiment that holds, helps hold things together. So this means that my first view of the rotation of this particular drawing is actually in the opposite direction. And that means that this AGC 203001 is rotating this way rather than, the other way, because the energy rotating it is coming up toward this and rotating like that. And then it comes here and it strikes it. And, as a possibility. I'm looking at that and I'm like, that means it as the wave is, first of all, the UGW is going to flip and it's going to be going the other direction, right? And it's going to be coming out like, not this way, but it's going to be coming out like this, and we're going this way through here. And I'll update this, I'll do a change 3 on this guy and send that to NASA here someday. NASA doesn't talk to me, but I just pester him with my PPT. I kill him with my PPTs. Death by PPT. All right. That's what we're looking at right here. Now, this is what got me started. Okay? So this, I don't even know what, I guess Gemmell's universe within a universe. At first, I thought maybe this was like a universal plane. And like we were basically looking at a very small universe within our own universe, just floating around, oddly. And then I was like, no. Then it became to me more of to be along the lines of a wormhole. All right. So if that's the case, that means that there are 5 other wormholes. And basically this particular wormhole, which is in this instance the butthole of the universe, it goes all the way to the center of our universe. And on the other side of that center of our universe is the other side of this wormhole. So now we're talking about space travel like all these scientists have been talking about. You could get into a wormhole and go boop, right from point A to point B, and bam, you're already on the other side of the universe. And it's like, this presents that possibility. The only trouble is, as we know with the sun and the earth, if you were to, say, get into those vortices and travel to the center of the earth, there's not going to be much of you left, and you're never going to make it to the other side. And it's just because there's one has molten lava, one has plasma going crazy, and each one probably has a rock in the middle of it that you go slamming into. So you're not going to get that far. My theory on the universe is that the universe, if it operates like a hurricane, it probably more likely has, say for instance, 5. It'll have a prime number of, I don't think 5 is a prime number, but it'll have like a prime number or an odd number of large, extraordinarily large black holes that in this case we could call them white holes, because the density of all of the stars in the universe might congregate around the center of the universe. But in this instance, the universe might have an eye like the eye of a storm. In that case, if you go through a wormhole, any one of these 6 primary wormholes, you might actually successfully travel from one side of the universe to the other side of the universe without piling yourself into a rock. Typically, you think about it, this would be the clearest area of travel in all of space, because it will be in the eye and nothing else will be in that eye except other travelers. And so, you might have a head-on collision with some sort of alien spacecraft, but what are the likelihoods of that? How busy are their highways? So, that's my point, ladies and gentlemen. All the other vortices, all the other 5 vortices, if this theory is correct, will be anticyclonic. That means they're sucking matter into the center of our universe, feeding those white holes at the center of our universe. And it's those white holes with their firing order, just like a distributor cap in an engine, firing off, and all that heat and energy rotates the universe. It's just an idea. It's not like I ever went to the center of the universe, so what do I know, right? But what do any of us know? I'm just as knowledgeable about that as the best scientist on the planet. It's like, I got a mind too. Hello. Anyway. So that's what we're probably looking at. And that could present the possibility of safe, universal-wide travel. And what happens when you go out here? You see, if this really is the butthole of, if this view that I'm showing you here really is the butthole of our universe, and it's the bottom of our universe, what's beyond that? Just straight up darkness? No, there's still lights out there. That means if you do travel through this wormhole from one side of our universe to the other, you're going to wind up possibly going right into another universe. And they're all butted together like a whole bunch of, what are those guys called that just populate all over the sea? They're jellyfish. I think, pretty sure they're jellyfish are called, and they wipe themselves out. Can't think of what they're called. War something. Anyway, mana wars. Yeah, just like so all these galaxies, or all the galaxies and everything are just like mana wars, floating around in different universes. And in some places you might have cold spots, and in those cold spots you have 0 Kelvin, where the cosmological constant is present and nothing moves, nothing happens. So my theory as it goes is, in this instance where the neutral hydrogen gas is being separated and neutralized by this particular event, that means that the stars that were in that galaxy at the time that they began to become stripped become stellar geodes. They still have molten activity going on inside of those stars, inside of their core. And their core might be solid-ish on the outside maybe, but it becomes more solid as it gets colder and they enter into this state of dormancy. And it's in that state of dormancy when, just like pouring slip into a mold with clay, and you pour it into this mold, and then it's always liquidous inside of there until you pour the liquid out and it leaves a shell. That's what happens with stars. Eventually, all of that liquid gets solidified, hardened, and then it just kind of like shrinks when it hardens. It's not liquid anymore, so it just kind of like it glues itself to the sides until you get a geode. And then at that point, you have all these strange gases that are trapped in there that end up turning that stellar geode into a deep freeze because they super cool under the certain circumstances in the conditions of the cosmological constant where they go into cold fusion. Because if you have the cosmological constant as the beginning of the cosmos in every aspect, you cannot create a universe from a hot flame, a hot explosion. It has to be cold fusion. Boom. Until that stellar geode reaches critical mass and bursts into the life of a new universe. That's my theory, right? Well, anyway. Just like we're not the only galaxy, we're not the only universe. So it just goes on and on and on and on. It's like looking through a million mirrors of yourself everywhere. All right, that's what I'm looking at here. Now this got me all started again. So here's what I'm doing. The next thing I did is I decided I need to go back, revisit my plotting of the Earth's galactic flight posture. I need to know what is our galaxy's true obliquity in relation to this ellipse that I'm looking at and you're looking at right now. What is it? Because that's going to tell us exactly what's going on with our galaxy in relation to this ellipse. And going back to Andromeda, I know I'm bouncing back and forth, but going back to Andromeda and our galaxy colliding, right? You've got some scientists on one hand taking a freaking bungee cord with a bunch of knots in it, pulling them apart and saying, this is our universe and this is what's happening. Oh, everybody's going away from everybody. Well, if that's the case, then why the hell is Andromeda coming at us? That doesn't make any sense. It's contrary to what that bungee cord is doing with its knots. So it's not the case. It's not true. It's not solid. What is solid is, yeah, you have expanding universe when all the knots are coming apart. Why? Because dark matter, the coldness of dark matter, which is part of stellar off-gassing in my theories, you have it expanding because all the gases burnt up and pooped out by our stars basically leave elements behind. And then those elements separate, just like the fat from the milk. The fat are your stellar nurseries, and the milk is your dark matter. And that dark matter just keeps building and building. Just ask the cow. It happens every time, every day. And you just keep building and building, and the cow goes, Mrr. All right, that's what our galaxy is doing. It's kind of like, Mrr. Oh, wait, not the galaxy. Well, maybe the galaxy too, but our universe is going, Mrr. It's getting stretched out and stuff. Shh, doodle, I'm talking. Okay, damn, I shouldn't have said doodle. Well, anyway, as it turns out, these are the things that are going on, and then, that does not explain the collision course of our two galaxies. So what could explain the collision course of our two galaxies is if we are flying through space like Toto in Wichita. I know Toto didn't fly through. Okay, the witches in Wichita when they're going around and they're going, that's us, that's our galaxy. So we're going around the column of this blooming invisible wormhole, and Eventually, as we reach the end, we may or may not collide, but we will most certainly, at this point of view, reach that event horizon. And that will be probably when our sun, as the Holy Bible talks about it, right? the sun will turn black as sackcloth. Well, if there's anything going to turn the sun black to sackcloth, it's going to be a cold event horizon of a wormhole. I'm just saying. So it's really important for us to keep an eye on that sun. I like we're going to be able to do anything if it decides to take that route, right? It's like, hurry, somebody go grab some plasma and throw it on the sun. We're running out of heat. Okay, well anyway. Okay, that I guess that concludes this video. I want to do the next one. I want to explain how it is that I ended up coming to my other discoveries. What are those other discoveries? Well, in order to I figured out the Earth. The Earth's flight posture, bam, not a problem. Why? Because all I got to do is go outside or take a photograph from somebody that somebody took of a specific known point. Take, for instance, Mount Rainier, and photograph the galaxy in relation to that known point, and where I can plot that person's position when they took that photograph, and bam, I can tell you where the galaxy is and how the Earth is positioned in relation to that galaxy based on my azimuth. However, really coming up with the true obliquity of the Earth's ecliptic and things of this nature in relation to our sun is a little more difficult, and then applying that obliquity in relation to our galaxy is again another little bit more difficult kind of a thing. So now we know what the ecliptic is. Well, scientists have told us what the ecliptic is for Earth, but is it really that? I mean, you look at photographs, and the photographs that are presented to you on the internet, you have the Earth tilting to the left, and then you have the Earth tilting to the right. So it is like, which is it? Are we tilting to the left or tilting to the right? Because that has a major impact on the ecliptic of our planet in relation to the solar system, and then the solar system in relation to the galaxy. Come on, it's extraordinarily important to know exactly how we sit and how these streams are affecting us. We're not going to be flying like straight through like a galaxy sitting on a pole rising up in a service station to get the car fixed. We're going to be at an angle. All that wind is going to be striking us at us from a side, from a corner, and rotating us, and we're going to have an obliquity in relation to the strength of that wind. Bam. Period. So I needed to figure it out. So where do I go to figure? I figured out the Earth. Now I need to figure out the sun. So I went to the SDO, Solar Dynamics Observatory, to figure out the sun. What I need are all of the photographs that they took of the sun during the spring equinox. I need to know what the sun looks like during the spring equinox, and then start measuring and plotting and mapping all of its axial tilts and axial cants in relation to the position of the SDO at the time it was photographed. Yeah, but the problem is, you can't go through the SDO gallery and just, oh, there's the picture I need right there. It's a, bam, it's just a bunch of freaking pictures, and you got to click on every damn single one of them to figure out what it's about. Great, though. That forced me to look at the sun under other ways, so I started looking at every single one of them, like, you know what? I'm seeing things here that I need to note and let people know that I'm analyzing. And so it took me off on a tangent, and that tangent has to do with differential rotation of celestial bodies. And those DRCBs are black holes, stars, gas giants, and terrestrial planets like Earth. Why? Because every single freaking one of them is a ball, space balls. The same, all spaceballs in our existence, in our universe, in the cosmos, are formed by the same forces. That's what I'm trying to say. It's a ball because there's a bunch of forces out there making it a ball. That puts all of these different types of balls into one category, the I'm a ball category. DRCBs. That's it. DRCBs is just a fancy way of saying space balls. All right. And you can't tell me I'm off because I don't know why anybody else hasn't come up with that point yet. What? Because everything is so round? No, because if you look at asteroids, some of them asteroids look like peanuts. How the hell you call that's not a DRCB? It's not even an RCB. Yes, we have RCBs too, rotating celestial bodies. But if it's round like a moon and it's a rotating celestial body and does not have differential rotation because maybe it's solidified, cleaned through, or turned into a geode or whatever the case, right? It still if it's rotating, it still has a rotation that is driven by another outside force, period. So it's an RCB. It's just not, it just doesn't have its own dynamo. That means it doesn't have any of its own gravity. You can have gravity shared by other objects that are differential, but if it doesn't have any of its own differential behavior, it's not going to have its own generation of gravity, short of being an object, because it is caught. If it is rotating, a ball rotating is rotating in a vortex, automatically makes it somewhat gravitational. That vortex it rotates in generates gravity, but it's not from within the ball that the gravity is being generated. It's all outside forces at this point. DRCBs, on the other hand, generate their own gravity in many ways. So every time any part of a DRCB pops up with a vortex, it pops up with another gravitational force. And the more vortices you have on a DRCB, take for instance Jupiter, the stronger that gravitational attraction and amplitude is. Bam! And that goes back to the cosmological common denominator is the vortex. Hello. All right. There we go. Okay. Damn, I'm just rattling on. I love listening to myself, talk to myself. All right. Now, let me see. Okay. So I started looking at the sun. And that's going to be the next thing that I talk about. In the next slide, I found evidence on the third picture I looked at from the SDO. I found a plasma stream vortex. What does that mean? On Jupiter, we have recently discovered that the stripes on Jupiter are formed by these stripe-wide vortices that are going around Jupiter, and they create like these contrails of gas and shit behind them, and they make the stripes. The sun has the exact same thing, and oh, by the way, this particular plasma stream vortex is going in the opposite direction of the sun's prograde direction of rotation. So it has a retrograde direction of travel. That means the sun has alternating currents. As far as I know, pretty much everybody's saying the sun's all going the same direction, and you just have slower speeds at the center and faster speeds at the poles, but pretty much it's all going the same way. Gong show, you got it wrong. It has alternating currents. I have proof of it, and I guarantee as I go through looking at every single one of those frickin' photographs, I will find more of these plasma stream vortices. And I decided to call it a plasma stream. Why? Because it's not gas in the way that we refer to a gas giant. So we say the gas giant has jet streams. Well, I say that the Earth has lithostreams. It's not gas, it's lithostreams. It's molten lava, but the properties of the operation are the same. So on Earth, it's lithostreams. On Jupiter, it's gas streams. On the Sun, it's plasma streams. Then I had other things that are beginning to come together and have to do with the formation, showing how the sun is working and how it operates, is exactly how the Earth formed its continents. And I'm going to explain how the Earth formed its continents. So basically, in essence, here's Africa, here's South America. They did not come apart like this. Plate tectonics. No, that's not how it happened. Now I have operational proof that is not how our continents came into came into being. Excuse me. So, it's exciting stuff, and it totally changes the outlook on everything that we probably think and believe we know about planetary evolution. And, oh, by the way, what else does it tell us? It tells us that stellar convection, mantle convection, and gaseous convection are identical in operation, period. Why? Because they're DRCBs. That's why. All DRCBs have six primary vortices, and all DRCBs have streams, alternating currents at a specific depth, to a specific depth in and near the surfaces of their bodies. And so when we take this into consideration, it gets pretty interesting how these things work. And it almost doesn't make sense. I mean, how do you get a vortex going in a circle like this and you get stripes passing through it? It's like, that is so weird. But as we're going to see, as I begin to tear down the sun and map all of these different forces, they don't necessarily operate quite like that. I mean, you will always pretty much be able to see the perimeters of these vortices, and you will see stripes going through, but you'll also see how the different things going on will, in some instances, cut a stream, cut it off, and stop it, and then you see all the material on the other side of that cut going like floaty, I don't know where the hell I'm going anymore stuff. All right. Yeah, all right. Now that concludes this video. Let's see, how long is this one? 34 minutes. That's a little bit shorter than the last one. All right, I'm going to go on to my next show, and then I'm going to publish this guy and see what happens. Okay. Don't forget to like and subscribe. All right, bye. Hold on. Don't go anywhere yet. I got to turn the thing off here somewhere.